So last week we looked at some similarity statements. So this is a similarity statement that reads, triangle ABC is similar to triangle DEF. Now I have these two triangles drawn out here, and you can see clearly that they're not the same size. Remember, similar means they're the same shape but different sizes. Now, one of the things that we looked at last week was that in similar figures, all of the corresponding angles are congruent. So we know which angles are corresponding to each other by looking at the similarity statement. The letters in the same position are going to be corresponding. So angle A is going to be congruent to angle D. So when I use the symbols, I can draw one arc at that angle to show that they are congruent. Since they both have one arc, that means they are congruent. Angle B is going to be congruent to angle E. So I'm going to draw this on the diagram with two arcs. That shows me that they are different from angle A and angle D, but they are congruent to each other. Then I have angle C and angle F, which I'm going to use three arcs to show that they are congruent. They are different from the other two angles, but they are congruent to each other. The other thing that we talked about with similar figures is that their side lengths are proportional. Now I have some lengths for each of the three sides of each triangle. So if you look here, I have the side AC with the length of 20, AB with the length of 5, and BC with the length of 15. And then in this triangle I have DE with a length of 1, EF with a length of 3, and DF with a length of 4. So we talked about the side lengths are proportional. In order to check if they're proportional, we need to take a ratio of the corresponding sides. For today, when we're looking at the proportions, we're going to set up some ratios of the corresponding sides. Now for today, it won't matter which one we put on top and which one we put on bottom, but going forward, we're going to be looking at triangles changing size. So we will have a starting point, an old figure, and we will have an ending point, a new figure. When we go forward, we always want to do new over old. We can also think of this as the image over the pre-image. In this example, I'm going to use the small triangle as my image and the large triangle as my pre-image. So when I find the proportions, if I want to see if it's proportional, I'm going to set up a ratio using the corresponding sides. I know which sides are corresponding using the similarity statement. So this will tell me that side AB, because those are the first two letters in the triangle, is going to correspond with DE, which are the first two of the second triangle. So I'm going to put the image of the small triangle on top and the large triangle on the bottom. So DE corresponds with AB, so I'm going to have 1 over 5. 1 is the length of DE, 5 is the length of AB. I'm going to do that for all three sides. I'll go next with BC. BC corresponds with EF. Those are the last two letters for both triangles. I'm putting the small on the top, so that's going to be 3, and the large one on the bottom, so that will be 15. And now, the last two sides, which are AC, the first and the last letter, and DF, the first and the last letter. So that will be 4 over 20. Now, these are three fractions, and if all three of them are equal to each other, then we can say that the corresponding sides are proportional, and we can confirm that these are similar figures. Now, 3 over 15, if we were to reduce that or simplify it, that would get us to 1 over 5. The same thing happens when we reduce 4 over 20. We get 1 over 5. So because all three of these reduce to 1 over 5, that shows us that these two triangles have proportional corresponding sides. They have congruent angles, which means they are similar. Now, this number 1 over 5, it means more than just checking if it's proportional. This actually tells us how much smaller this triangle is than the large triangle. That is called the scale factor. A scale factor is a number that tells us how much bigger or smaller an image is to the pre-image. So in this case, if our pre-image was triangle ABC and our image was triangle DEF, the scale factor tells us how much smaller the image is, triangle DEF, is than the pre-image, which is triangle ABC. Now we use the letter K to represent the scale factor. So if we're talking about K, K can have one of two values. K, which is our scale factor, will always be positive. That's the first thing. The second thing is that it can either be greater than 1 or it can be less than 1. Now the 0 over here just tells us that it's going to be a positive number. That's the reason why the 0 is here. If K is bigger than 1, then we will have what's called an enlargement. Enlargement sounds exactly what it is. It means it's getting larger, it's getting bigger. If K is less than 1, that means we have what's called a reduction. This figure gets smaller or it shrinks. To find the scale factor, we just have to find the ratio of corresponding sides. If two figures are similar, it doesn't matter which pair of corresponding sides you use to find the scale factor. Because the corresponding sides are proportional, they're all going to have the same ratio when they are reduced or simplified. So in this case, we can find the scale factor by taking the length of the side of the image over the length of the corresponding side of the pre-image. So we always do image over pre-image. You want your new figure over your old figure. So I'll go ahead and write that as well. New over old. If you're getting bigger, then you want the big over the small. If it's getting smaller, then you want the small over the big. In the example that we looked at earlier, we got this ratio of 1 over 5. Well, that would be our scale factor. That means that the triangle DEF is 1/5 of the size of the triangle ABC. And we can see that because each of these corresponding sides get reduced or get divided by 5. They get 1/5 smaller.